The problem I'll be demonstrating today is from the 2002 FRQ problem number 2, and it deals with the rate at which people enter amusement park and then the rate at which the people leave. Now before you start any problem, it's always important to look at what information is given to you. In this case, we have E of t, which gives us the rate at which people enter the amusement park, and we have L of t, which gives us the rate at which people leave the amusement park. Now, as you read further, you see that both E of t and L of t have the units of people per hour, and that the time interval with which you are working is between 9 and 23 hours after midnight. Okay, now that you've read all the conditions of the problem and know what information is given to you that you have to work with, you're ready to move on to actually solving the problem. Now part A is fairly straightforward. It asks you how many people have entered the park by 5 p.m., which is when t equals 17. Now you can find this answer simply by using an integral. Let's get started by determining the limits that you will apply to your integral. So if we look at the part A, it asks us to evaluate at t equals 17. So we know that will be the ending point of our limits. And then if we look back to the problem, we see that the interval starts at t equals 9. So now we know that is the beginning of our limits. So therefore, the limits of your integral will be from 9 to 17. Just doing that without anything else will give you 1 point out of the 3 that are awarded for part A. Alright, now that you know your limits, let's actually find the function that we'll be using in the integral. Now it's asking for how many people have entered the park, so when you look back in the original problem, you see that the rate at which people enter the park is given by E of t. So therefore, the integral is of E of t. And that will give you your second point on part A. Now you could solve this integral by writing it out by hand, but why not make your life a lot simpler and just use a calculator? If you want to solve an integral on the TI-89 calculator, you first hit the second button, then the 7, which will bring up the integral symbol with an open parentheses. In that parentheses, you type in the function you want to integrate, then comma, x, because you're taking it with respect to x, another comma, and your lower bound number, and then last comma, and your upper bound number, and close the parentheses and hit solve, which gives us an answer of 6004.27. However, the problem asks for you to round to the nearest number since it's people and you can't have 0.27 of a person. So we will write the answer as 6004 and then include our units, which is people in the park. And that will give you your third and final point for part A, and you're now ready to move on to part B. Now part B takes a little more thought and work, but it's still asking a pretty straightforward question. Reading the problem, you can see that it gives you the information that at t equals 17 or 5 p.m., the price of admission is $15. However, after 5 p.m., the price changes to $11. Now the question wants to know how many dollars are collected in total following these price constraints on a given day. Now if we look back into the original problem, you can see that a day for the park goes from t equals 9 to t equals 23. However, only from the time when t equals 9 until t equals 17 are they charging $15 before they switch to charging $11. So now you know that you'll have to split your integrals up into 2 parts. Let's start by finding out how much money they've made when they were charging $15 for admission. So first, you will write 15, because that's how much money they are charging, so that's what you will multiply the integral by. Then you're going to actually set up your integral, and we notice from time t equals 9 to t equals 17, because that is when they switch their prices. Also, the function will be, again, E of t, because you're charging people for coming in and not leaving. You're now ready to set up your second interval, so you'll add it to the first, and you're going to multiply it by 11, because that's the price for this time period. And your limits will be from 17, so that's where we left off on the last one, till 23, because that is when the park closes. And again, the function will be E of t. Now we already know the value of this integral since we found it in part A, so we can simply write 15 times 6004. Then you can go back to the calculator and using the same method we did in part A, evaluate this integral. And doing so gives us the value of 1,271. And now it's simply an algebraic problem that you can solve with your calculator as well. And in doing so, you get 104,041. And make sure you add the units, which is dollars. Now part B is only worth 1 point, and it's actually only given for having the correct setup. So as long as you got the first part correct, as in having two integrals with the correct limits, you will get that 1 point. Now part C starts off by giving us a bit of new information, such as the function h of t, and the value that is found by plugging 17 into h of t. Reading further, you see the question is asking you to find a value given by plugging 17 into the derivative of h of t, and then explain the meaning of h of 17 and then the derivative h of 17. Now, since the function h of t is the integral of ex minus lx, then that means the derivative of h of t would simply be ex minus lx. Now we can confidently assume that h of 17 is therefore equal to E17 minus L17. So looking back at the original problem, we see that that is the E of t and the L of t we'll be working with. So you'll plug in 17 to both of those. Alright, and in doing so, we're given these two lovely fractions that are simply just algebraic work that needs to be done on a calculator preferably. And in doing so, gives you the answer of negative 380.281. Getting that correct value gives you one of the 3 points available for this problem. Now we're going to move on to defining h of 17 and the derivative h of 17 to get those remaining 2 out of the 3 points. Since a function h is first the rate at which people are entering the park minus the rate at which people are leaving the park, the total will give you the amount of people that are in the park at a given time. By plugging 17 into the function of h, we'll know how many people are in the park at t equals 17, or at 5 p.m. By using the calculator, we can see that h of 17 is equal to 3,725. Now, to get that second point, we need to write an explanation of what this means, so we can say something like this. We can tell that h of 17 means that at time t equals 17, there are 3,725 people in the park. Now we already know the value that is generated by plugging 17 into the derivative of h, but now we just need to give a definition to what that means. Since the function of h is the amount of people entering the park minus the amount of people leaving the park, we know that the derivative of h is the rate at which the amount of people in the park is changing. So using that knowledge, we can get an idea of what plugging 17 into the derivative of h means. So we can say that the derivative of h of 17 means the number of people in the park was decreasing at a rate of 300 people per hour at t equals 17. And that will give you your third and final point for part C. Alright, now we're going to move on to the last part, which is part D. Now this question is asking at what time that the model predicts the number of people in the park is at its maximum. And the model that they're referring to is the one given in the problem above, h of t. Now the model they're referring to is the function we found in the problem above, which is the derivative of h of t, which is e of x minus l of x. Alright, so to find when something is at its maximum, we first need to find its critical numbers. And to do that, we're going to set the function equal to 0. And in doing so, these are the functions you have to work with. Now you can plug this into your calculator to find the exact value at which t equals 0. Now, for this equation, we got two answers, 15.79 and 46.45. However, we remember from our original stipulations of the problem that the interval we are working with is only from 9 till 23. So therefore, 15 is the only answer that will work. You can now write your answer as t equals 15.794, because we found that is when the function will reach its maximum number of people. And this problem is worth 2 points. The first one is given for just having the correct function set equal to 0, and the second is for having the correct answer. And with that, you've now completed the entire FRQ and understand how to get full credit on each of the problems given. But if you're still struggling with these concepts, or maybe just feel like you want some extra practice, there are other FRQs you can look at. Another similar problem is taken from the 2008 FRQ, question number 2. Use the same types of integrals and derivatives that we did in the previous problem to find the rates at which people enter the line and the amount of tickets sold.